welcome back to 12.3, multiplying rational expressions. Multiply rational expressions. The multiplication expression above is similar to the multiplication of rational expressions. Recall that to multiply rational numbers expressed as fractions, you multiply the numerator and you multiply the denominator. You can use the same method to multiply rational expressions. Example 1, expressions involving monomials. A. Find 5ab cubed over 8c squared times 16c cubed over 15a squared b. And then they tell you there are two methods for solving these problems. Method 1 is to divide out the greatest common factor after multiplying. So if you look on the board, you'll see I've done that. Here's our original problem, and then I went term by term to multiply it all together. 5 times 16 is 80, a times 1 is a, b cubed times 1 is b cubed, c cubed times 1 is c cubed. 8 times 15 is 120, a cubed times 1, or not a cubed, a squared times 1 is a squared, b times 1 is b, and then c squared times 1 is c squared. Next they say after you multiply, divide out your GCF. So then you have to ask yourself, what is my GCF between my constants and my variables? Between 80 and 120, your GCF is 40. Between a and a squared, your GCF is a single a. Between b squared, or b cubed, and b, your GCF is a single b as well. And your only difference here is between c cubed and c squared. Your greatest common value is 2 c's, so c squared. Now you're going to rewrite the problem by dividing out the GCF. So we're going to take the GCF out of our numerator, and we're going to see what's left with. So 80 divided by 40 is 2. So once we pull out the GCF from 80, we're left with 40 and 2. Next, we're going to pull out our a's. If we pull out our a GCF from both our original, it's going to cancel out. So a is going to be on the outside now, and it's canceled out on the inside. We're going to pull out the GCF of b from b cubed. So we originally had b cubed. We said our GCF was a single b. So we're going to pull out that b, and we're left with b squared on the inside. On the outside, we originally had c cubed, and we're going to pull out a c squared. So here's the c squared we pulled out, and we're left with 1c left on the inside. Repeat for your denominator. So we originally had 120. We're going to pull out a 40. 120 divided by 40 is 3. So 40 on the outside, 3 on the inside. We originally had a squared, but we're pulling out an a. So a squared with one a pulled out leaves one a left inside. We originally had a b, but we're going to pull out a b, cancels out our b's. We originally had c squared, but our GCF had a c squared, so we're going to pull that out, and that cancels. So now on the outside of our parentheses, we have our GCFs, and whatever was left after we pulled them out. Next, cancel out your GCFs, and then whatever was left inside of your parentheses is your final answer. So that's method 1. Method 2, however, says divide out any common factors before multiplying. So, we're going to erase this, and now we're going to look at this problem. We're going to pull out any common factors before we multiply through division. So when we're dividing fractions, remember we're working at an angle. We're taking this top piece and comparing it to this bottom piece. So we say 5 goes into 15 how many times? 5 goes in once, and I'm left with a 3. And we're going to repeat that for every process. A over a squared. Well, this a is just going to get canceled out, and we're going to have to pull out one a that got canceled out from a squared, and now we're just going to be left with a single a. B cubed compared to b. Well, this b to the third is going to cancel out one of these b's, so that b is going to go away, but it went away here too, and now we're going to be left with b squared on top. Repeat the process now at this diagonal, comparing our first denominator to our second numerator. 8 goes into 16 twice. So cancel that out and put a 2 up here. And now we have c squared and c to the third. Well, this c squared is going to get canceled out because of the c to the third. And we're going to have 1c left up top. And now we just kind of multiply it straight across. We have b squared times 2 times c. So list your coefficient first, 2, and then do alphabetical order. B squared times c, all over 1 times 1 times 3 times a, which is just 3a. And so we've solved the same problem, but you'll notice this one goes by much faster so long as you stay organized on where you are canceling out. Next, let's look at example 1, part B. Alright. In example 1, part B, we have 12xy squared, oops, that's important, over 45 mp squared times 27 m to the third p over 40x cubed y. And we're going to do the same thing. We're going to look at our cross products and see if there's any cancellations that we can do. So going from our top numerator to our second denominator, we're going to look at our coefficients first. What can be canceled out between 12 and 40? Well, a 4 can. They both share a common 4. If we divide out a 4 from 12, we're left with a 3. If we divide out a 4 from 40, we're left with 10. We have x and x to the third. This x is going to get canceled out with one of these x's. Because it went away, it canceled out one of these x's, and now we're left with x squared. We have y squared over y. One of these y's is going to get canceled out, and this y is just going to go away. And now we're left with y up top. Repeat the process again. What is their greatest common factor between 45 and 27? That's a 9. 9 goes into 45 5 times. 9 goes into 27 3 times. We have an m and an m cubed. M goes into m cubed twice. And this m gets canceled out. We have p squared and p. Well, p goes into p squared twice, but it'll get canceled out in the process, leaving a single p down below. And now we just multiply straight across again. We have 3 times 3 up top, so 3 times 3 is going to be 9, times y times m squared, go in alphabetical order, so m squared, y up top. Next we have 5 times 10, which is 50. P just times itself, which is p, or times 1 times itself. And then x squared. And we're left with our final answer. Flipping the page, on to example 2. Sometimes you must factor a quadratic expression before you can simplify the product of a rational expression. Example 2. Expressions involving polynomials. For A, we have the expression x minus 5 over x times x squared over x squared minus 2x minus 15. So step 1 is you have to factor your polynomials to see if you have any GCFs that you can cancel out. So looking at 15, 15 is negative, so it's a positive times a negative number, and 2 is negative, so my bigger number is going to be negative. So if I take the numbers 3 and 5, 3 times 5 is 15, but negative 5 plus 3 is negative 2. So I found my factors. So rewriting my expression, I have x minus 5 over x times x squared over, copy down this, your factored form, x plus 3, x minus 5. And now you'll see I have something to cancel out. I have x minus 5 and x minus 5. So I can go ahead and cancel out those expressions. And I have an x and an x squared. X squared is going to cancel out this x and make it just a 1. And that's going to turn this into a single x because we pulled out a common x from them. And you'll be able to see our final answer. This whole expression canceled out to a 1. So now I'm just left with x over x plus 3 times 1, if you will, because that 1 is still there. But anything times 1 is just itself. So our final answer is x over x plus 3. So that's example 2a. Let's look at example 2b. For example 2b, we have a squared plus 7a plus 10 over a plus 1 times 3a plus 3 over a plus 2. Right off the bat, we see we have a trinomial, so now we're going to have to factor it. And then also, if you notice at this binomial, we have a GCF of a 3 that we're going to end up having to factor out. So we have a GCF that's 3, and we want to remember to pull that out as well. So if we're looking here, we're looking for 2 factors of 10 that sum to a positive 7, I think, don't you? Yep. And that means we have 5 and 2. 5 times 2 is 10, but 5 plus 2 is 7. So if we go ahead and factor this now, we have a plus 5 times a plus 2 all over a plus 1 times, we're going to pull out this 3 now, 3 times a plus 1 over a plus 2. And now we can see we have double what we can cancel out. We have a plus 1 here and a plus 1 here. And now we have a plus 2 here and a plus 2 here. So if we continue to multiply that out, we have a plus 5 really over 1 times this 3 is still here. Our sets connected to a have been canceled out, but that 3 is still there, times 3 over 1. So now we just get the expression of 3 times a plus 5, or you could write it as 3a plus 15. And there you go. That's all for today's lesson, and you can begin your homework.